We want to show that omega, which is this expression here, is a cube root of unity, and state the other two roots in polar form. Well, let's look at this. This is in Cartesian form, clearly. So it would be down here. This is root 3 over 2 and a half. Using Pythagoras, 3 over 4 add 1 over 4 is just equal to 1. Square root of 1 is 1. And it would be the inverse tangent of 1 over root 3, which is pi by 6. Now remember where it is. Okay, so there's our region. So that is going to be cis negative pi by 6 squared. Now in the denominator we have to be careful with this one because there's a minus there. But we can turn it into a cis by making it cis negative pi by 10. And that's because cos is an even function, so cos of negative pi by 10 is the same as cos of pi by 10. But sine is an odd function, so the sine of negative pi by 10 is the negative of sine pi by 10. So we can make this cis negative pi by 10, and then that is to the power 5. And then this one is already a cis, so that's going to be cis pi on 30 to the power 25. So that is going to be cis of negative pi by 3. Now 5 pi by 10 is obviously going to be pi by 2, so that's going to be cis negative pi by 2. And then this one will be cis 25 pi by 30. And that would cancel down to 5 pi by 6. So what do we need to do? On the bottom here, we're going to add the angles. So negative pi by 2 plus 5 pi by 6. Which is negative 3 pi by 6, add 5 pi by 6. So that's 2 pi by 6 or pi by 3. So we've got cis negative pi by 3 divided by cis of pi by 3. And therefore that is going to be equal to cis negative 2 pi by 3. Now, we need to show that it's a cube root of unity. Cis of negative 2 pi by 3 cubed is equal to cis of negative 2 pi, which is equal to 1. Now we want to state the other two in polar form. Now this is coming up in a later part of the question, but we know that these things are equally distributed. The one we just found, the omega, like so, and so they're going to be distributed like this, and they'll be 2 pi by 3 apart. So we know that the omega is cis negative 2 pi by 3, but then the other roots would be omega squared, which is, you don't have to call it that, but it would be cis 2 pi by 3, and then you have just 1, which of course is cis 0. So those are the other roots. And then we're asked to represent the cube roots of unity on the grid below, which is just basically formalizing this sketch. So 2 pi by 3 is here. Remember, the modulus is 1 for each of these. And so they should all lie on the circumference of the circle with radius 1. And I'm going to label them 1 omega and omega squared. So we want to express each of the roots in Cartesian form and hence show that 1 plus omega squared is 0. Now we know that our omega was cis negative 2 pi by 3. So we know that is cos negative 2 pi by 3 plus I sine negative 2 pi by 3. Now that's in the t quadrant, and therefore cosine and sine are both negative. The cosine of negative 2 pi by 3 is negative a half, and the sine of negative 2 pi by 3 will be negative root 3 on 2. So we've got negative root 3 on 2i. Now our omega squared is cis 2 pi by 3, and by exactly the same method you'd find that's negative a half plus root 3 on 2i. And of course 1 is just 1. And so we have 1 plus negative a half take root 3 on 2i plus negative a half plus root 3 on 2i. And we can see there's going to be some cancelling here. The 1 will cancel with the negative half and negative half, and these will cancel, and therefore it's equal to 0 as required. Now finally we want to find the fifth roots of z equals a half plus root 3 over 2i in polar form. So if we go a half and root 3 on 2, again just like at the beginning, Pythagoras is going to tell the Sliss length is 1, and the tangent here would have root 3 over 1, or just root 3, telling us that this angle is pi by 3. Therefore z is going to be cis pi on 3 plus 2n pi, where n is an integer. So the fifth roots are going to be cis of pi by 15 plus 2n pi divided by 5. And n still clearly is an integer. Now, if n is equal to negative 2, then what we get is cis pi by 15. Take away